Hello, today we'll talk about the basics of solving systems of linear equations. Last time we talked a little bit about what they are, and we'll dip our toes into the method of solving them. Let me just recall from last time that we observed an important fact. A system of m equations in n unknowns can have 0, 1, or infinitely many solutions. Okay? So again, that's an important fact. We'll see that over and over again. I'm going to repeat myself. So our question, the kind of the main question then is, given an m by n system, okay, so this is my notation that I have m equations and n unknowns. This is the number of equations, and this is the number of variables or unknowns. If you give me one of these, what I first want to do is, well, I know, just going into the game, I know that there's going to be 0, 1, or infinitely many. The first thing I want to know is, there's sort of two questions is, does there exist any solution? All right, so remember, a solution is going to be an assignment of numbers that when I plug into each equation works, right? It satisfies those m equations. And then the second one is, if so, how many are there? So again, since I know that there's 0, 1, or infinitely many, the first question says is, am I in the 0 case or one of these two other cases? And then if I go to 2, that means I've ruled out the 0 case, and I just want to know, is there 1 or infinitely many? So just some buzzwords here. This is usually called the question of existence of a solution. And then once I know that there is a solution, right, then it's how many are there? So I want to know, is the solution unique? So this is usually called the uniqueness question, okay? Okay, but this is the general strategy for solving a system. And we'll see that there's going to be, not today, but in the maybe next lecture, we'll see that there's sort of two steps in the algorithm to answer these questions. And let me give you some, let me start this process with an example. So e.g., let's consider a 3 by 3 system. I don't know, let's see, x1 minus 2x2 plus x3 equals 0. All right, there's 3 variables, and there's going to be 3 unknowns, so it means I have to have 2 more equations. Okay, so then 5x1 minus 5x3 equals 10. I'm pretty sure I took this example from your book, so you can read along there if you like. So the first thing we're going to do is notice that when I write down a system, it's a little bit, it's too much information. We actually don't need to write down all these things. I don't need to keep writing down the variables every time. So the first step is going to be to encode this system in, I guess 2 different matrices. So a matrix, so maybe you've seen this word. I don't know if you guys are too young to have seen the Matrix movies, but a matrix for us is just going to be a list of numbers, and it's a kind of fancy word for a simple thing. All I'm going to do is take this system and basically just ignore the x1, x2, x3, and just write down the numbers that I see, the coefficients. So I see that in the first row, I see a 1, a minus 2, a 1. And then what I do is I put a little dash line here to indicate that there was an equal sign. I put a 0, okay? So my matrix, I have these kind of big brackets that kind of tell me where to list my numbers. Now in the second line, I've got a 0 x1, because there is no, right, the coefficient of x1 is 0. I've got a 2, a minus 8, and an 8, right? This is 5, 0, minus 5 equals 10. So this is what's called the augmented matrix of the system. And sometimes it's going to be useful to, not actually think about the right-hand side of the equations, just think about what are called the coefficients, remember. So that's 1 minus 2, 1, 0, 2 minus 8, 5, 0, minus 5. This is what's called the coefficient matrix because I'm only looking at the coefficients. Okay? But the point here is that the augmented matrix, is the same information as the system itself. So I might as well just, and from here on out, we'll slowly start only talking about the augmented matrix as a system because it's the same information. Okay, so how do we solve such a thing? Right, so maybe I can continue here. If you give me such an augmented matrix, right, which we know is encoding a system, how do we solve? So how to solve the system. And the basic idea is going to be to eliminate variables. And our convention will be that we moving left to right and top to bottom. Okay? So we're going to see that there's a choice of how to solve these things. And our convention will be that we move left to right, top to bottom. So what do I mean by that? Well, this should hopefully be familiar if you've looked at smaller systems, right? Say 2x2 systems. Remember, this is encoding x1 minus x2 plus x3 equals 0. So what I'm going to do is I'm going to take this thing, this first equation, and I'm going to look at this coefficient of x1. And what I want to do is clear every instance of x1 that comes below it. So I want to keep this x1 and clear all the other instances of x1 that occurs in the other equation. So here, I'm kind of lucky that there is no instance of x1 in the second equation. But what I'm going to do is I'm going to replace equation 3 with, so I'm going to take this equation and I'm going to replace it with minus 5 times the first equation plus it. So I'm going to take minus 5 times equation 1 plus equation 3. Okay, so this is my notation for equation, just EQ. Okay, so what I'm going to do is take, what is minus 5 times equation 1? That's minus 5, 10, minus 5, 0. And I'm going to add that to equation 3. Okay, so what I get is, now here I'm only replacing equation 3. So equation 1 stays as it is. Equation 2 stays as it is because I'm not touching that. And now I'm going to take minus 5 times this first row. Each entry gets minus 5, and I add it to the third row here. So if I take minus 5 times 1, I add it to 5, that's 0. That's what I wanted. If I take minus 5 times minus 2, that's 10. I add it to 0. That gives me 10. If I take minus 5 times 1, that's minus 5. I add it to minus 5. That's minus 10. Minus 5 times 0 plus 10 is 10. Okay? Okay, and so what I get is now here, right? This is now a new system of equations, right? This is an augmented matrix. So now it's saying x1 minus x2 plus x3 equals 0, etc. This is 0x1 plus 2x2 minus 8x3 equals 8. There's 3 equations, but we see that's a bit simpler than we had before. And what I'm going to do now is continue. So I've cleared all the instances of x1. I'm moving left to right, like I said, right? Left to right. So I now see that there's instances of x2 happening in my what's called the next pivot position, okay? And what I'm going to do now is I want to clear below this x2 instance. I want to clear below, but what I'm going to first do is, if you remember before, it was useful to have a 1 as the entry here. So I'm going to replace equation 2 with 1/2 times equation 2, right? I can scale an equation. That doesn't change the equation, the solution set. So what I'm going to do is just leave equation 1 alone. Scale equation 2 by 1/2, meaning I multiply everything by 1/2, and I get this. Okay? And now what I'm going to do is do that clearing thing. So now I'm going to say, well, now I have a 1 in that position, so I want to clear every instance of x2 below it. So what I'm going to do is I'm going to replace equation 3 now with minus 10 times equation 2 plus equation 3. So I'm going to take minus 10 times this equation. So I leave equation 1 alone as before. Leave equation 2 alone because I'm only replacing equation 3. I'm replacing equation 3 with minus 10 times equation 2 plus equation 3. So minus 10 times 1 plus 10 is 0. That's why we chose that. Minus 10 times minus 4 is 40. Plus minus 10 is 30, right? Minus 10 times 4 is minus 40, plus 10 is minus 30. And I've got this. And now this is another equation, a system of equations, and it's even easier. And notice now, this is what's going to be called upper triangular. You know, if you think about where the non-zero entries are, they form this kind of triangle that sits, you know, above the diagonal. It's called upper triangular. We'll make that more precise. This is also sometimes called echelon form, which I'll make more precise later, but just to give you a taste of this. But the point now is that we can now solve this thing. You know, the point now is we can reverse substitute. So in this form, we can what's called back substitute to find our solutions if they exist. Okay? And what I'm going to do when I say back substitute, I'm going to go from the bottom to the top now. So we kind of eliminated top to bottom, but I'm going to now go bottom to top. So what is this last equation saying now? Equation 3 is now saying 0x1 plus 0x2 plus 30x3 equals minus 30. Well, that's pretty easy to solve, right? That tells me that x3 equals minus 1. Okay, great. We know what x3 is. But what's equation 2 now saying? This is saying that 1 times x2 minus 4 times x3, which I know is minus 1 now, equals 4. Right? I know that x3 is minus 1. So when I take this equation, I can plug in what x3 is. So what is this telling me? It's telling me that x2 equals, well, is that 4 minus 4, I guess, right? Okay. Okay, good. Now we know x3, we know x2. And what is equation 1 saying? It's saying 1 times x1 minus 2 times x2, which we now know is 0, plus 1 times x3, which we now know is minus 1, equals 0. This is telling me that x1 equals 1, it looks like. X1 equals 1, because this is x1 minus 1 equals 0. And so this is telling me what the solution is. So the solution is unique. There's one and only one, is x1 equals 1, x2 equals 0, x3 equals minus 1. Okay, and so, you know, that's basically going to be our strategy. We're going to make more precise. Let me, yeah, I think we'll end here, and I'll continue this next time with the more sort of precise recipe for solving these things. But again, let me just emphasize that as we were making these moves, we got to a place where back substitution would actually tell me that a solution exists. And, you know, I went through the steps here to actually get the solution, but I could tell that I would be able to solve for this just by looking at this matrix as it is here. Okay, and so this is the theme that we'll continue next time.